Salvete amici et discipuli. Nomen meus est Theoremus Antiquitus Magister Mathematicae. Hodie formulas angulorum summae doceo. Sinus alpha plus beta aequalem sinus alpha cosinus beta plus cosinus alpha sinus beta. Cosinus alpha plus beta aequalem cosinus alpha cosinus beta minus sinus alpha sinus beta. Okay. Haectamus Latine intellegis? Comprende? Rozumiete? Good, let's get to it. All right, so as you can see, yes, today we are doing the sum angle formulas, and our basic setup is, I like to think of it as a simple setup, kind of a rectangular setup with four right angle triangles inside. And here is the basic setup. We have angle alpha, and then we have angle beta, and the two of them make angle alpha plus beta. Okay? And so if we have this kind of a setup, you have angle alpha plus beta here. These are parallel lines. This angle must be alpha plus beta. Okay, you see that. That's the way it is. And also, what about this angle here? Well, look at this. This is alpha. This is 90 degrees. So this is 90 minus alpha. Well, look, this angle has to add up to 180 degrees. So you got 90 minus alpha plus 90. This has to be plus alpha. So that's probably the biggest challenge in this whole setup, is figuring out what this angle is. This is alpha, same as this. And this angle is alpha plus beta. And we make this hypotenuse over here 1. We put the right angle here. And we start from the inside with this hypotenuse of 1. And we know that once we have the hypotenuse and we have an angle, well, now we know what these side lengths are. The opposite is sine beta, and the adjacent is cosine beta. So now we have these two, and they also form a hypotenuse. But anyway, so here we have that. Also, if this is a hypotenuse of 1 and this is the angle of alpha plus beta, well, the adjacent would be cosine of alpha plus beta. That's this distance here. And the opposite is sine of alpha plus beta. Okay, so now we have these two. Great. So let's work on these. This is angle alpha, and we have a hypotenuse of cosine beta. Therefore, the opposite is sine of alpha times the hypotenuse cosine beta. And the adjacent is, again, cosine of alpha times its hypotenuse, which is cosine beta. So now we have these two. And the remaining ones will be here. So we have an angle alpha. And so here's the opposite. So that must be sine of alpha times its hypotenuse, which is sine of beta. And similarly, the adjacent is a cosine of alpha times its hypotenuse, sine of beta. At this point, we have all the information that we need. And basically, to get to the double angle formula for sine of alpha plus beta, we work on these vertical lines. The sine of alpha plus beta, that equals these segments. There it is. Sine alpha cosine beta, this one, that's DE, plus cosine alpha sine beta, that's CD. These two are equal to this in terms of line segment. That's line segment arithmetic. All right? And similarly, for the cosine of alpha plus beta, well, look at this. We work on these horizontal lines, and you notice that segment OE is equal to AB plus BC. And we are after, of course, the cosine of alpha plus beta. And so we must get the difference between segment OE minus, segment BC. So cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. That gives us cosine alpha plus beta. Pretty simple. You have a simple diagram, things work out nice. I've seen more complicated diagrams, things that look like this, and I generally don't like it. I've seen that on the internet. If you take a look, it's equivalent, but it's more complicated in my opinion. So I don't like this kind of a diagram. Just more taxing. But, here we have our formulas. And notice, so we have a sine of a plus b and cosine a plus b. If we use the odd and even function symmetry of trig functions, well, guess what? We know that cosine of minus beta minus b equals cosine of b. This is a even symmetry. And sine of minus b equals negative sine of b. You get a negative sign right there. Minus sine. That's called odd symmetry. And if you actually do that, you plug in sine a minus b. Well, the cosine, that stays positive. But look at the sine. That changes, becomes negative right here. So we get a negative because of this negative sign here. And similarly, we're working on cosine of alpha minus beta. So if we replace b with a negative b, cosine of a negative b, that's the same as cosine of b. That's called even symmetry. And of course, this term here, the sine of negative b, well, that will change the sign. This becomes a minus sign. So minus times a minus becomes a plus. And that's how we get this bottom formula. And so we can get all four formulas out of just a simple little diagram like this. I think this is the way to go. So, okay. Thank you.